Welcome to the course on design of power electronic converters. So we had started with the module on gate drivers, and we saw the introduction to gate drivers. What is gate driver? What is the need of it? What does it require to do? And then we also saw some equations related to estimation of a gate driver requirements, means your power requirements and current and voltage requirements. Now today we will be discussing the first type of gate driver, which is your optocoupler based gate driver. So previous lectures I had told you about the requirements of gate drivers. So what it needs to do is that you meet the voltage and current requirements of gate emitter or source region. Then it needs to provide isolation. Now this isolation can be of different form. It may be an optical isolation or it may be magnetic isolation. And then it needs to do level shifting. It should be able to work with floating supplies, and it should also be able to give high impedance input. So these were the requirements, main requirements that we had seen for gate driver circuits. Now, so there are various different types of gate drivers are there, and in this course we will not be discussing all of them. We will be discussing only the ones which are widely used, and the first among them is optocoupler based gate driver. So, what is an optocoupler? You might have heard this term before. It is basically an electronic component that connects two separate circuits by using light sensitive interfaces. So basically you have a photodiode, or you can say that a light emitting diode, which when turned on it is going to emit light, and then on the other side you may be having a transistor or a diode, which is again a light sensitive, a photosensitive device. So for example, here this kind of an optocoupler, what is going to happen is whenever this light is emitted over here, then this transistor starts to conduct because it falls into its base region and then it conducts. So what we have there is when you give a gate pulse like this, so whenever this is high, this gets turned on, it starts to conduct, and then because of this light emitting diode, this transistor gets forward biased, and this also starts to conduct. Okay. So that is how you get also a signal over here. Now this is one configuration. There are other configurations as well. This is another configuration where the coupling is via two photosensitive diodes. Okay. Now these photosensitive diodes is usually operates in the reverse biased region. Now we will not be discussing too much about this optical isolation and about the photodiodes details. You can read all these things on your own. If you Google, you will get a lot of information about all these things. So, we will not be taking up, just to know that what is important for this course for you to understand is that these optocoupler based gate drivers, they used optocouplers, and these are your optocouplers which are generally used, and they provide optical isolation. And this isolation usually is in the range of up to 10 kilovolts. So, the first requirement of voltage and current requirements of gate region, that yet it does not seem to be being satisfied just by using this kind of an optocoupler, but yeah, optical isolation can be provided. And when we say level shifting, yeah, this can be connected to different voltage levels. So yeah, level shifting should be possible, that you are able to see somewhat, but you do not see the voltage and current requirements of gate region can be met by just this kind of a transistor or diode. So then what has to be done for that? So for that what people use is what is called as a totem pole. So you have this kind of an optocoupler, and then this optocoupler's pulse, whatever it comes on the output side, that is given to this totem pole. It's a combination of an NPN and PNP transistor, and so you can see here that whenever this pulse is high, so pulse is high, it's given to both of them. Since this is NPN, NPN means whenever this is high, this is going to conduct, and PNP, if the base is high, then that is not going to conduct, it will be in the cutoff. So therefore, then what will happen is that whenever the gate pulse is high, this is high, so this starts to conduct and the current flows like this. Alright, so that is how we can turn on this IGBT, and then we can connect, we can make this Vs as whatever is required by this gate emitter region. Okay. And these can be a transistor which have the ability to supply the current that is required by this gate emitter region. Then next, when this gate pulse goes low over here, so at that time what happens is that low means PNP will start to conduct and NPN will go into cutoff. So then what will happen if PNP conducts, means what is the direction of the current is going to be like this. That means when we want to turn off this IGBT, then the pulse goes low and this PNP will be able to sink whatever was this gate emitter region charge that was there with the help of this gate current IG. So if we just choose proper totem pole transistors NP and PNP as per the requirement of the gate emitter regions IG requirement, the gate current requirement, then we have the current source and sink ability, and we also have to choose the plus Vs and minus Vs according to the gate emitter regions requirement. So then now we are able to meet the voltage and current requirements of the gate emitter or gate source region. So the first requirement of driver is also met, and we also have the optical isolation, and plus another thing is that the level shifting, that over here your levels may be very small, it may be, let us say, from 0 to 3.3 volt it may be there, and over here we may require something like, let us say, plus 15 and let us say minus 8 volt. So that also is obtained. So level shifting is also obtained, and this usually won't be needing your very large amount of current, so high input impedance is also obtained. And this over here, this is whatever is the supply that is given, that is with respect to this emitter, and this then if we have a separate power supply, a floating power supply, then your this kind of a driver will also be able to work with floating supply. Okay, so all these requirements that we saw can be met by this kind of an arrangement of an optocoupler plus your totem pole combination. So over here now what we see is that this voltage that we provide, that has to be with respect to this emitter or the source in case of MOSFET. So we need floating supply. So then we have to have an arrangement to be able to obtain floating supply. So that is again shown here. So this is your isolation, this is basically your gate driver which provides, in case of optocoupler based gate driver, you have the optical isolation, plus you will be having the totem pole, and then this is your gate emitter region, and this IC will be given the supply using a floating source whose reference will be your this emitter region. Now there are different ways by which floating supplies are obtained. one of the ways is using isolated DC to DC power supply ICs. So, what are these ICs? These basically contains your isolated DC to DC converters inside them. You might have studied them before: flyback converter, forward converter, push pull and so forth. So, those kind of isolated DC to DC converters may be inside one IC, okay, and then those ICs are available, power supply ICs, and you can use them for your gate drivers. This is one of the ways. Another way is that you may not use ready-made IC, but you can make a floating power supply of your own. You can make a small isolated DC to DC converters or converter of your own for using half bridge configuration or full bridge configuration, or whatever is suitable for based on your auxiliary circuits, whatever may be available for your design. Okay. And then there are other methods also where the floating supply may be generated using what's called as a bootstrapping method, which we will be discussing later on. So, there could be various ways of obtaining the floating supply, okay, and but for this optocoupler based gate drivers, you have to have an arrangement to generate the floating supply if your converter has position of IGBTs or MOSFETs such that the emitter or the source point floats for some of the IGBTs or MOSFETs. So, now what are these isolated DC to DC power supply ICs? Usually they will have your input side where you can give whatever supply that may be specified in the data sheet of that IC. This may be a low voltage or a medium voltage, whatever voltage, 5 volt, 10 volt, or that will be specified by the manufacturer. And then usually they will have this kind of outputs, 3 terminals, where you have plus VG, that means your whatever plus 15 volt or 18 volt, 20 volt, whatever is required by your this power electronic device. Then it will have the reference, that is the common with respect to which this plus Vg will be obtained. Then usually they may be also having a negative output with respect to the reference, because many times these IGBTs or MOSFETs, they are given a negative voltage to turn off. Alright, and these power supply ICs, they are especially made to be used for drivers. So, now let us look into what are the important specifications of these floating power supply ICs. So, one important specification is the output current. Now, output current, why is it important? Because whatever your this will be able to give over here, whatever is the output current that this will be providing, that is what should be sufficient to be able to meet the IG peak. Okay. So, output current specification of this IC should be greater than IG peak that you will estimate for your gate driver. Then the output voltage, so when you choose this power supply IC, the Vg should be sufficient enough to be able to drive this gate emitter region. So, you should also check for the output voltage. Then of course, this input voltage, that also this VCC also you should be checking for. Because then this also has to be given by some means to the whatever the PCB that you are going to use. So, this also has to be checked then. So, your input voltage, then further what is important is to look for the ripple in the output voltage. Now, why is this ripple important? Because if you have this Vg and let us say this VG has got some kind of a ripple like this. This is your VG output that is going to come. Now, whatever is this ripple that is there, that is going to affect this driver circuit, okay, and this is usually a very sensitive circuit. Driver is actually the most important part of the power electronic design. If the driver's design in that PCB layout everything is not proper, then it leads to a lot of electromagnetic interference issues, and you will see a lot of unexpected things happening. Sometimes it starts, sometimes it suddenly turns off. Okay, so I mean it becomes very sensitive to noise. So that is why this ripple in the voltage plays a very important role of this floating supply. It should be as stable as possible, as much as ripple free as possible. So the ripple content in VG you should be checking for the power supply ICs, whatever you are going to use. Then next one is your coupling capacitor. Now, what happens is that you have a coupling between the input and the output. Okay. Now, this is your coupling capacitor. Now, this is a parasitic, it is unwanted, but it is there, you can't really 100% get rid of it, but it should be as low as possible. And this is a problem, and it leads to a lot of common mode currents and interferences. Those things we will be looking into later on in the course, but know that this coupling capacitor is what appears between the input and the output, and it should be as low as possible, because there is always going to be a coupling current, you can call it as ICOUP. So, that is an unwanted current, and it basically is going to reduce the isolation level, and it will also lead to your interference problems. And next one is your isolation voltage. Now, you have to check for the isolation level, that till how much voltage level, 10 kV, 5 kV, what is the isolation voltage level up to which this IC that you are going to use, it provides the isolation. Because then if it is not going to give you isolation for the voltage range for which you are going to use your IGBTs, then you basically you have an isolated power supply IC, but it won't be useful for you. So, that isolation voltage level also you should be checking for. And there may be several other parameters that may be given in the data sheet of these power supply ICs, so that you can look into it, but these are the important ones which you should be looking for while choosing that power supply IC for your design. Next, let us look into the important specifications of gate drivers. For that, I have taken this example of one leg of an edge bridge, and this is your optocoupler based gate driver, where you have this optocoupler, and then this totem pole arrangement is also there. Now, what you have over here on this side is the PWM inputs that is going to be coming, okay, PWM 1 and PWM 2 for these two IGBTs, and then the output is going to be given appearing on this VO point. Now, this VO is two of them have the same VO. This is how usually the ICs are, two of them have the output voltages, and they have to be connected together, and then using this gate resistor, this is connected to the gate of the IGBTs. And then one of these, this is your reference, this is your N, the negative bus, and this is your P, the positive bus. Now this is not floating, so their reference of this lower driver is fixed, it does not float. So you do not need a floating supply over here, a fixed supply will do. Whereas over here for this point you have your emitter point to be floating, this we have seen before. So you need a floating supply over here. So for this driver you need a floating supply, and as we had also seen before, this is called as the high side driver and this is called as the low side driver. Now what are the important specifications that you should be looking for choosing this gate driver? So those, the first one is of course your peak output current. Second is the switching speed. Now peak output current, last lecture we saw how to calculate the peak output current requirement for turning on or turning off these IGBTs and MOSFETs. So your gate driver, whatever you choose, should be able to supply the peak output current. So peak output current that this driver should be able to supply, that should be greater than what you obtain here as your Vg by Rg. Okay, and then your switching speed, now you have a certain requirement of your switching frequency, let us say 50 kilohertz or 100 kilohertz, whatever. So your driver should be able to switch at that frequency. Those switching speed specification of the gate driver should be greater than the switching frequency that you will be choosing for your design. Next is your operating voltage. Now operating voltage, this Vg level, that whatever you provide here, that should be sufficient enough for this gate emitter region to be driven. So your this voltage has to be proper. Next is this VPWM1, whatever the voltage it can allow, it should be compatible with whatever controller you are using. That controller, whatever voltage it is giving as output, 3.3 volt, 5 volt or whatever other 15 volt, whatever voltage it is giving, that much input voltage over here this driver should be able to allow. So operating voltages of the gate driver IC also you should be checking for. Then next you should look for propagation delay. This is something I'll explain to you what it is little later. Then is your isolation level. This of course is going to be important because we for optocoupler based driver or any other driver you are using, if you are providing isolation, what is the level of that isolation, that you should be checking for. Then is your capacitive coupling. Now as I told you for your floating power supply IC, similarly for your optocoupler based gate drivers also you will be having this your coupling capacitor between this input side and output side. Okay. So that also you have to check what is the capacitive coupling, it should not be too high. And next one is your CMTI, common mode transient immunity. This also I will explain you little later. Okay. So these are the important specifications of gate drivers which you should be careful for while selecting the optocoupler based gate driver IC. So what are the key points of this lecture? Optical isolation is provided by your optocoupler based gate drivers. Next is that it needs a separate DC supply and if you have floating emitters or floating source in your circuit, power electronic circuit, then it also will be needing floating power supply ICs, but it needs a separate DC power supplies. Okay, so that's actually one of the what you can say the disadvantage of optocoupler based IC, because it makes it a little expensive. But overall optocoupler based gate drivers, they give very good performance and are very widely used. And then the other important specifications that you should be looking for is your input and output voltages, peak current output, switching speed, propagation delay, oscillation levels, and CMTI. Thank you.